Hello, this is Miraj Patel, and today we're going to be starting Unit 5, which is all about ionic bonding. And before we talk about ionic bonding is bonding caused by the transfer of electrons. And you can see in this picture that this electron is being transferred to Cl, or chlorine, and this causes a bond, and this causes a sodium chloride. And see how the electron is transferred to chlorine from sodium. And so ionic bonding has to pretty much do with the valence electrons. And valence electrons, I'm sure you know, are the electrons in the highest energy level. And the group number is the same number as the valence electrons. And the valence electrons, like we talked about in Unit 4 and 3, they determine the chemical properties of an element. And these are the electrons that are involved in bonding, and they're involved in ionic bonding as well as covalent bonding, which we'll talk about in the next unit. And here are the Lewis dot diagrams, and these show the valence electrons. And so these are the groups, so 1, 2, 3, 4, 5, 6, 7, 8. And these are the same corresponding number of valence electrons. And the octet rule says that atoms like to form bonds to have 8 valence electrons. So all these atoms are pretty much like jealous of these noble gases, and they want to have 8. So that is why elements like to bond to form 8 valence electrons. And pretty much they like to also fill the outer shell, and this is just like noble gases. So pretty much because these elements don't have 8 except for the noble gases, they want to get to 8. So that is why noble gases don't want to get rid or lose any electrons, because they're happy with their 8 valence electrons. And so to get to 8, some elements lose and some elements gain electrons. And depending on where they are, which columns they are, we can know if they're going to lose or gain. So the first 3 columns, they want to lose electrons because it's easier to lose 1, 2, or 3 electrons than to gain 7, 6, or 5 electrons. So it's easier to lose a few than to gain a lot. And the vice versa with the columns 5, 6, and 7. It's easier to gain maybe 3, 2, or 1 electron than to lose 5, 6, or 7. And don't worry about column 4 because we won't be talking about that. This column can go either way, so this is a little bit confusing. So just don't worry about group 4. And the elements, because they want to get to octets, they form ions, which are pretty much elements that lost or gain a few electrons. And metals, which are on the left side of the periodic table, form, they lose electrons and they form positive cations because they lose a few negative particles. And nonmetals gain a few electrons and they form anions, or negative ions. And so for example, above you can tell sodium is the cation because it loses an electron and gives it to chlorine, and chlorine is the anion, and it's because that chlorine gained 1 electron. So you can tell, and you can tell by the charge. See how Cl is negative and Na is positive. So that is how you tell if an ion in an ionic bond is uh, an anion or a cation. An ion, sorry, in a chemical formula. And so here we're going to go over a few groups. And so group 1 has 1 valence electron, And in order to get 8, it's easy for it to lose 1 electron. So because it loses one negative particle, it becomes positive, and that is how it gets a +1 charge. And same thing with group 2. Group 2 has only 2 electrons, and it's easy for it to just lose 2 and become a +2 charge. And then we have group 3, which is all the way past the d orbital over here where aluminum is. And again, it's easier for group 3 to lose 3 electrons, and because it loses 3 electrons, it gets a +3 charge when it loses 3 electrons. And so pretty much this is what we talked about just so far. Group 1 is a +1 charge, group 2 is a +2 charge, and group 3 is a +3 charge. And now we're going to the right side of the periodic table, and we have group 7, group 6, and group 5. So in order, if you have 7 valence electrons, if you want to get 8, you can gain 1. And if you gain 1 electron, you'll have a -1 charge because you gained 1 extra negative particle. And same thing with 6, but instead you need 2 electrons, so you would have a -2 charge because you need 2 electrons, because 6 plus 2 is 8. And then if you're group 5, you need 3 electrons, so you would have a -3 charge. And it's important when you're naming these ions, anions names end in IDE. And also, the anions are always second in the name. So like for example, sodium chloride. Chlorine here you can see is an anion because it's a negative charge, and sodium is the cation, so sodium goes first, then chlorine. But instead of saying sodium chlorine, we add IDE to the end of the name, so it's sodium chloride. And so just let you know about the name. And so this diagram pretty much just shows the Lewis dot diagrams for these ionic bonds. So pretty much you just draw the Lewis dot structures for each element that's going to be participating in the bond, and then after the arrow you put the first cation in brackets with a plus sign, where it's just its charge after how many electrons it lost. So if it was, for example, if it was magnesium, it would be +2. And then the anion just gets a new electron, so pretty much you fill up its Lewis dot structure, and then you count its charge based off of how many electrons it gets. So this one would be Na with no electrons because it went to Cl, and the Cl will have a negative charge. And so this is pretty much what we talked about. So these first 3 are all positive because they lose electrons. These 3 are negative because they gain electrons. And we'll be talking more about transition metals later on. And even though that they vary, they're always positive. So just as a side note, just put on the back of your head. So these are always positive. And let's do a few examples. Write the names and symbols for each of the following ions. And when you write the symbol, we have to include the charges. So iodine gains blank electrons to form blank. So iodine is in group 7A, so it has 7 electrons. So it's easier for iodine to gain or lose a few electrons. It's easier for iodine to gain 1 electron than to lose 7 electrons. So iodine gains 1 electron, and if after gaining 1 electron, what does the charge become? Well, the charge, if it gains 1 negative substance, it becomes 1 negative. So the charge will be just iodine, so you just write I, the atomic symbol, and then you write the negative sign. And then here we have number 2. Calcium loses blank ions to form blank. And so calcium is in row 2A. And if you're in row 2A, you have 2 valence electrons. So is it easier for calcium to gain 6 electrons or lose 2? Well, calcium, it's easy for calcium to just lose 2 instead of gaining 6. And so calcium loses 2 electrons, and if you lose 2 negative things, what do you become? You have now a plus 2 charge because you lost 2 negatives and you were just balanced. So there's more positives than negatives. And so that's how you get the 2 plus charge. And so sulfur blanks electrons to form blank. So sulfur is in group 6A, and so if you're in group 6A, you have 6 valence electrons. It's easier for sulfur to gain 2 electrons than to lose 6. So sulfur definitely gains 2 electrons, and because it gains 2 electrons, it gets 2 more negatives, so it becomes S negative 2. And potassium blanks electrons to form blank. Potassium is K, and it's in the first column, and potassium has 1 valence electron, so it's easier for potassium to lose 1 than to gain 7 valence electrons to form an octet. And so potassium loses 1 electron to form, and after losing 1 negative, you become positive. So it's K plus because it only lost 1 electron. And so notice how whatever this number is, it's the same charge, the same number. But if it loses electrons, it becomes positive, and if it gains, it becomes negative. Just as a side note. And so here's a quick quiz. How does oxygen display the octet rule when forming an ion? A loses 2 electrons to form a negative 2 charged anion. B loses 6 electrons to form a 6 plus charged cation. C gains 2 electrons to form a negative 2 charged anion, or gains 2 electrons to form a 2 plus charged cation. Well, let's just use our common sense to see which answers are false. So if you lose electrons, if you lose 2 negative things, you become positive. So A is wrong just by looking at the answer. It doesn't even make sense because how can you lose 2 negatives but become more negative? So that is false. And also, when you gain electrons, you have to become negative. So D is wrong because it says you gain 2 electrons but become more positive. That doesn't make sense, at least here on Earth. So A and D are out. And oxygen, let's just look at where it is. So oxygen has 6 valence electrons, so it's in 6A. And it needs to gain 2 electrons to form an octet. So the answer is definitely C, because it needs to gain 2 electrons, and because it gains 2 electrons, it gets a negative 2 charge. And so, question 2, atoms tend to gain a noble gas electron configuration by losing valence electrons. Are A metals, B nonmetals, C halogens, or D anions? So, if you remember, just from the PowerPoint, the metals are the elements that have valence electrons usually less than 4, so it's easier for them just to lose a few electrons than to gain a lot more. So the correct answer is A, but if you did not know that, you could sort of just go through all these answers and figure them out. So D doesn't make sense, anions. Uh, it says atoms, so anions aren't really atoms, they're ions. So these don't make sense. Halogens are group 7A, and if you have 7 valence electrons, it's easier to just gain a few electrons than to lose a lot of electrons, or lose 7 in this case. And also B, nonmetals are on the left side, so on the left side you have more valence electrons, and so it's easier also for them to gain a few, but this one says lose electrons, so that is definitely the metals. And question 3, when bromine atom forms an anion, it does so by A, losing 2 electrons, B, gaining 2 electrons, C, losing 1 electron, or D, gaining 1 electron. So first of all, an anion is a negative particle. So to be negative, you have to gain electrons. So you can eliminate A and C because losing electrons will make it positive, which would be a cation. So eliminate C and A, and then B, gain 2 electrons, or D, gain 1 electron. So we have to go to bromine. Bromine is in column 7A, so it has 7 valence electrons, and it needs to get 8. So 8 minus 7 is 1. So it would have to gain 1 electron. And so the correct answer is D. And so here's the last question for this PowerPoint. Write the name and symbol of the ion formed from a nitrogen atom. So A, nitrogen ion, N3+, B, nitride, N-, C, nitride, N3-, D, nitrogen ion, N5-. So let's just look at nitrogen. So nitrogen is with the nonmetals, so it's most likely gonna gain a few electrons. And it's in 5A, so 8 minus 5 is 3, so it needs to gain 3 electrons. So if you gain electrons, you become negative, negative. So the correct answer is C. Just by looking at how many electrons it will gain, you can figure out that it'll gain 3 and become a -3 charge. So the correct answer is C. And also, you could have eliminated that because it becomes an anion, it will have a nitride name because all anions, like sodium chloride, they end in IDE if they're negative anion. So you could figure that out too. And so the next PowerPoint is about naming these formulas. And so ionic bonds and formulas. So we're going to talk about naming these and finding the charges and making the formula unit. So ionic compounds are composed of cations and anions, but they are electrically neutral, so pretty much they have a charge of 0, so they cancel out. And ionic bonds, like this one, so Na and Cl, are an electrostatic attraction between positive and negative ions in ionic compounds. And the whole reason all has to do with valence electrons in the octet rule. So they want to get 8 electrons. And binary compounds are compounds that only contain 2 different atoms. And a chemical formula shows the type and number of atoms in a substance. And formula unit is the lowest whole number ratio of an atoms in an ionic compound. So the important part is lowest whole number ratio. So we could, if you can divide both of these by a common factor, then it's not the lowest whole number ratio. So it's important. So for example, 2 and 2 can both be divided by 2. So the correct formula would be CAS without these 2's. And same thing with this one. You can both divide these both by 2. So you can, it's pretty much like simplifying fractions. They have to be the lowest possible numbers. And so these all are examples of not formulas because 2 and 2 simplify to 1 and 1. Again, 2 and 2 is wrong because it can simplify to 1 and 1. And 2 and 4 can simplify to 1 and 2. And so we'll talk more about that in the next next slide. So writing formulas for ionic compounds. So first we have to write the symbol of the cation first. So always the metal goes first, then the nonmetal. So here we have an example, K and O. So K is the cation because it's a metal, and O is the anion because it's a nonmetal. And then we have to first write the charge of each ion as a superscript or sort of an exponent. And then we write the subscripts. So we pretty much just balance the charges by crisscrossing. So just remember 3, pretty much just crisscross the charges. And then we just erase these charge symbols. So we just get rid of the negative sign and positive sign. And if there's a 1, we don't have to write anything. So pretty much after crisscrossing, we get K2O. And so pretty much, just to check, you can always see that if we have two 1 plus ions, the charge will equal to just one negative 2 charge. So this is pretty much just what it's showing. So if we have two pluses, we counteract one negative 2. So these just two cancel out. And let's just do another example, magnesium nitride. And so we have the two symbols. Then we write the charges. We crisscross the charges. So we have Mg3 and N2. And we just erase the charges. And we get this. And just to check, if we have 3 Mg2 pluses, we just multiply the 3, because we have 3 of these, 3 Mg's times its charge, so Mg has a charge of 2 plus, and then we multiply 2 times the negative charge of nitrogen, because we have 2 nitrogens. The two charges should equal each other, and it should cancel out. So this could be like a little check step if you want to ever check. But this method, you always pretty much works. And so here we have several formulas in word form, and we're going to convert to their formulas. So calcium oxide, so calcium is Ca, and then oxide is O. So we find their charges on the periodic table. So if it's in 2A, it's a 2 plus, and if it's in 6A, it's a 2 negative. So we crisscross the charges. So it would be Ca2, but an O2, but we have this, we only have Ca and O. So this is correct because we have to find out the lowest ratio. So like simplifying. So 2 to 2, we can just simplify as 1 to 1. Because both 2 and 2 can be divided by 2. So that's how we got this. Just like math. Simplifying fractions. So it's the same exact thing. And so aluminum oxide, aluminum and oxygen. Aluminum has a charge of 3 plus because it's in column 3A. Aluminum is in 6A, so it's a charge of negative 2. Crisscross, and then we just write the numbers. And this is in simplest form because there's nothing that goes into both 2 and 3 besides 1. Then we have magnesium phosphide, so Mg 2 plus and then P3 negative. Crisscross charges, and same thing. 3 and 2, there's nothing that in common, so it's just the same number. And then lithium sulfide, LiS2. So we crisscross charges, so Li2 and then S. And pretty much this is the simplest form, so there's nothing to do. And so here's a quick quiz to see what you learned. Write the chemical formula, or which chemical formula is correct. So let's look at A. So K and O. So K has a charge of +1, but O has a charge of -2. So these two charges don't equal each other. So this one is incorrect. And so let's look at the second one, Mg and S. So Mg has a charge of 2 plus, S has a charge of 2 minus. So if we have 1 2 plus but 2 minuses, the charges don't equal each other because we pretty much have a 2 plus and a 4 negative. So this would not equal. So B is out. And then C, Ca or O. So Ca has a charge of 2 plus and O has a charge of 2 minus. So ding ding ding, we have a correct answer because the charges equal each other. So as soon as the charges are equal, so if we happen to have a 2 plus, 2 minus, 1 plus, 1 minus, 3 plus, 3 minus, and the charges are just equal, we have a correct answer. So the correct answer is C. And so which chemical formula is incorrect? K and F, CAS, MgO, or NaBr. So let's go through the first one, K and F. So potassium has a charge of 1 plus, fluorine has a charge of 1 minus. So normally the correct form would be K and F, because just K and F by themselves equal each other out, because 1 minus and 1 plus just equals 0. So if we have two negatives and one positive, that is just a negative 1 charge. So A is incorrect. So the correct answer is A. And so all of these, if you look at them, Ca and S both have a charge of 2, but this is positive, this one's negative, so 2 plus and 2 minus cancel each other out. Mg and O, Mg has a charge of 2 plus, O has a charge of 2 minus, so these cancel out, they work. And Na and Br, Na has a charge of 1 plus, Br has a charge of 1 minus, and they also cancel out. So all these work except A. And pretty much just a summary, the the metals on the left side are all pretty much positive, because it's easier for them to lose a few electrons to get uh, 8 electrons, and they become positive because of this. And then we have the nonmetals on the left, and they pretty much gain a few electrons instead of losing a lot, so they become more negative. And column 4A is the weird one because it can go either way, so just don't worry about this yet. And here we have the transition metals, which we'll be talking about later on in a few videos. And that is it for this video. And I would like to thank Miss Harper for providing me with the PowerPoints and knowledge to teach it to you guys. And I hope this helped you learn about ions, ionic bonding. And the next video will be about polyatomic ions and transition metal ions, so those ions in the middle that have varying charges, and we'll talk more about that. And we'll see you later, and I hope you have a good day.